Mm-hmm.
Yeah. Do you see my screen?
Not yet. Now it's changing. Yeah, now I see your screen.
Good. What is the program for today? Which presentation you would like to?
We stopped with the curtain injection, I think, right?
Right.
Or we did it, right?
Let's double check it. Definitely, you explained to me what is the basic idea, and this is I remember.
Yeah, we stopped with the joints.
Yeah, I think we did not.
Yeah, we did that.
This is we did. Yeah.
Yeah, we did the project reference, and then we stopped with the joints.
Yeah, this one.
Yeah.
Good. Okay.
Again?
Yeah. Do you hear me well? And do you see me well?
Yeah.
Uh-huh. Okay. My understanding of MC Inject Gel 95 is that this is first of all for cracks. Where we have cracks in concrete, we can use this material.
No, it's
No?
for joints. For joints.
For joints.
Yeah, not for cracks.
But joints somehow it's also cracked.
Yeah.
But made before.
A plant crack.
Plant crack, right? Yeah.
So you use this material for joints, for movement joint, expansion joints, yeah, in order to seal it. But every time, yeah, the task is not to like a crack injection. It is to build a block, yeah, that the joint is sealed.
Okay. And this is 45 degrees. We install Parker and fill gap between two concrete plates, right?
Yeah, but from the back side of the joint, right here you see this rubber gasket, yeah, which is broken in the picture, and this black, yeah, that is the water stop, the water bar.
Mm-hmm.
And when this is broken, yeah, you inject from the side of the soil the material.
Uh-huh. And crack in this water stop part.
It just should show that there is a leakage.
I see. And usually, is it rubber or what is the material? Because I'm not familiar with this technology.
Yeah, usually it's rubber.
Usually it's rubber. Mm-hmm. Okay. And what is on the next picture?
Wait, I've get a call right now. I will skip it. So, oh wait, I have to put my phone to unavailable.
Thank you.
Wait. Okay.
Is it a different type of water stop rubber?
Yeah, that's it. That's different kinds of water stop and sealing of movement and expansion joints. So that is just shows different kinds of application.
I see. Okay, and in some cases we can install Parkers vertically, not 45 degrees. I see, right?
Yeah, just if you want to go outside because you're drilling through the whole construction and you're reaching the soil, and so you're injecting into the soil to seal the structure.
I see. Okay. Okay, I understand.
Okay.
Next slide or something else here.
Yeah, just the system, yeah, with the 2-component pump, different components, yeah. Some key facts. Yeah.
Soft elastics, swelling effect 20-30%, elasticity, elongation at break. What does it mean, elongation at break?
That is when you make a specimen and pull it. Yeah. And it could expand 300, so nearly 400 percentage, and then it breaks. So that's elasticity.
Is the same like elasticity?
Yeah, elasticity is measured in a joint with 1 centimeter thickness, and then you have two concrete slabs, 1 centimeter joint, and then you pull concrete slabs.
Okay, I understand. Polymer reinforced, very good injectability, water impermeable, hardening under vibration, fast steerable reaction time. It means one of the important properties that this is also for structure where you have some movement.
Yeah.
Right? Like bridges, like car parks, slabs where cars are moving. This is important. Okay, I understand. Measurement joint sealant.
Yeah.
That
is now an example. Yeah, just an example from a tunnel where you have this tubing segments, tunnel segments, and the joints between. Yeah, and when these joints are leaking, yeah, you have to do an injection, and that is done with a gel.
Okay, and what does it mean 1100 joints leaking in some examples?
Yeah. It was in a project in Denmark, yeah, where they had 1,300 joints and 1,100 were leaking.
Oh,
just a project information.
I see. Poor guys, but happy MC people who can repair it. I see. Yeah, this is another example. Okay, such MC
that is that is a so-called needle packer, relatively new invented, where you can put it directly into the joint, so you don't have to drill. Yeah, you can pierce through this gasket, through this rubber, and inject directly behind.
Here, like this.
Yeah, like this, and like you see here, on the other pictures also.
But this is the rubber, right?
This is the rubber, yeah.
Yeah, but this I don't quite understand. This packer
on the right picture, you have two segments which are coming together.
Right.
And both of them have this gasket there. And these segments are sealed just due to the pressure on the gaskets. And when they are leaking, you can pierce through this joint directly through the gasket and inject behind the gasket.
I see. Okay, good. This I never seen. I saw a few times gel 95 with just normal part. This I never seen. Okay, this
just
example.
Pictures from the job site. Yeah, just material storage, so mixing. There you can see the normal injection, right? So where you have the packers beside the joint and inject like on the pictures what you have seen in the beginning.
And this green line, what is that?
That is just from something different. That had nothing to do with injection.
Okay.
That is the result where you can see, okay, the material is behind the segments there.
Okay. Nice result.
Yeah. Sealed. this sealing of joints is relatively easy because you just have to go through the joint or besides the joint to the other side of the building, so to the soil side, and inject their material to make something like a plug from the outside.
Okay.
And yeah, that is the whole thing what you have to do.
Okay, now I have better understanding. That's it with this presentation?
That's it, yeah.
Okay. I wanted, flyer maybe this. Yeah. Just to double check, because I believe on this picture, main idea in very short condensed way, right?
Yeah.
What we are doing in injection. Let me repeat that I understand it correctly. First type of cracks, water-bearing cracks. This is wall. We have water from outside, and we need to stop the water. We can use this in MC inject, high elastic crack activity. I forgot what type of injection.
Again?
I forgot what is the type of injection, MC inject 2300.
That is polyurethane, flexible polyurethane.
Flexible polyurethane, yeah. And this is first area of application. Second, static. We don't have water there, yeah. We have cracks and we need to consolidate it, or no, we need to bring strengths back. Yeah, and for this we use another type of injection for force fitting. Yeah. Cracks. And what is this type of injection?
Epoxy.
Polyurethane first, epoxy second. Yeah. Number 3. Also without water, but static. Yeah, where we don't have movement. Right?
Yeah.
Strengthen as cavity filling, centrocrete. This is mineral based.
This is mineral based, yeah.
Mineral based. Oh, at least I remember one. Mineral based. And number 4. This is where we have water, right? Outside, we need to stop it. MC inject 3000 joint surface, and this is where foam is generated, right?
Well, what?
Foam. Is it foam injection?
Foam? No.
No?
So, again, that is, these bubbles look like foam, but that is a curtain injection. Yeah.
This is curtain. And type of injection, is it also polyurethane?
No, it's acrylic gel.
Acrylic. It means first polyurethane.
That is like GL95.
Yeah, first polyurethane, second epoxy, third mineral based, and fourth acrylic. Okay, I understand, and all of them in details in that 3 presentation, which we look through. Okay, Markus, what's next I can learn today?
We can go on with the consolidation and structural lifting.
Actually, I already met 2 or 3 companies who are specialized just in lifting technology here.
Mm-hmm.
In Canada, it's interesting. Usually, people use one type of injection and specialize there. Small companies, 3-5 people, and only one type of injection.
Mm-hmm.
Help protect. Okay. Basic of soil injection testing method and success control. Principle, flowing process, test method, success control. Injection of
that is what we already had when we talked about the soil injection is a curtain injection.
Yeah, we already saw it.
Oh wait, I get a call. Wait.
Sure.
Treinen. Ich habe jetzt keine Zeit. Tut mir leid. Ja, besser morgen. Super. Ja, ebenso. Tschüss. Okay.
Markus, I remember this picture, but I don't remember this one. Do we need to discuss it?
That is just that you. So, I think we don't have to discuss it in detail, but you just have to know that you have a total volume of air inside of pore space inside the soil. But you cannot fill the full space with material. That's the 85% which we had. Do you remember?
Yep.
Yeah. That's it. You don't need to know anything else.
Okay. Consumption. This is we discussed flowing process and consumption.
Yeah. So from one spot, the material will flow in a sphere in the soil, and that is just the same thing, just for a pile. Yeah. So
yeah, we discussed it. Yeah.
Another shape of injection specimen, but yeah. This picture shows that no matter if you're injecting overhead on the wall or at the bottom, the material will spread like a sphere in the soil. It will spread like a ball, not different. Yeah.
And how this is inside the ground? And
yeah.
How they injected this? From outside or?
No, that looks like it's inside the soil. That is on top. They filled it with sand and injected from the side.
Okay. It means after injection they put back sand outside of the.
Yeah.
That's right. Okay. And this is just testing?
That was testing for a tunnel project. Yeah. This shows you that every soil has a so-called KF value. That is a value which you can measure according to some guidelines. Yeah, that is done with water pumping from one point to another point. And depending on the speed, you will find out the KF value. And if the KF value that you will find in the geotechnical report, if the KF value is lower than 10⁻⁻⁷, we are talking about silt and clay, and then you cannot eject inside the pores of the soil. So in the end, that just gives you the information that if your soil is too compact, too less space inside, you cannot eject. You will frack the soil, like you see in the picture.
Okay. It means as more consolidated soil, as less chance that you will successfully inject a material, right?
Yeah.
From other side, if there is too weak soil, you will inject a lot because a lot of space in the soil, right?
Yeah.
And just for my memory, and there is a formula how you can calculate, depends on the porosity of the soil, how much material you can customer can expect to use or to pay for it, right?
Yeah.
How do you find the type of soil? So you cannot dig and take samples. The technique as well as application has to be least intrusive, or else the customer might even think of demolishing. Wow. Conventional soil strata analysis.
That is just that you see what different kinds of tests you can do to find out what kind of soil you have, the different layers and so on. But in general, you will do the cheapest test is the one on the next slides, this comb penetration test.
Yeah, before we go there, and understand if we have more or less complicated projects, we need to ask specialized company like this one to come and to make tests and to give us an independent report, and they are responsible for the data. Right?
Yeah.
What's that? No.
That should just show you, there are some methods for soil analysis which are non-destructive, where you have where you don't need to destroy the building and dig out something, where you can just use a radar or some electronical devices which can just without any additional measures can measure the kind of soil and the depth of the layers and so on.
I see.
Yeah.
Okay, but we don't do it usually.
No.
We ask somebody to come and to do it.
Yeah.
Yeah.
That is not we, the customer.
Customer, yeah. Basic of soil injection principle, success control. Standard cone penetration test. Okay, what's that?
That is a standard test which is used for this kind of which is a fast and cheap test for analyze the soil. Yeah, that is just this cone which is hammered inside the soil, and by counting the hits, per 10 centimeter of depth, you can just see what kind of soil you have.
Okay, and this is also done by specialized company.
Geotechnical company.
Yeah. Test result before injection, after injection. This is to prove that injections were made.
And that is this comb penetration test, yeah? This video shows now the next topic, or the first topic of slab lifting and slab fixing.
Bearing clear subsoil. Typical problem.
Yeah.
Nice video.
Is it
also
Russia
made in Russia? Great. What kind of injection of that?
This is a silicate, MC Montanject CB, but yeah.
Okay. Airport.
Yeah, you see where you can use it. Yeah, just showing the application areas.
Roads. Warehouses, typical problem for warehouses. And in Canada, I saw a few companies who are doing this because a lot of small houses in America, and a lot of problems like this.
Yeah.
People specialize here. Is it profitable business for MC?
To lift up the houses.
No, I mean to sell this injection, this type of injection, because I don't know margins for different type of injections.
Yeah, we do several jobs right now. We have done several jobs with this kind of application.
Do you know what is the typical DB1 for silicate injection? No?
55.
55. It means good but average, nothing extraordinary.
Yeah, because we are talking about big volumes, and that was the reason why we have decided to make this MC Montan inject materials. Yeah.
Driven concrete for high load capacity resistant long time, high load capacity link concrete surface under production.
Just shows what is the advantage of driven concrete slabs. Yeah.
Value preserve, no downtime. What does it mean, no downtime?
Yeah, so no stop of the business. Yeah, if you have an industrial storage hall,
I understand.
You have just small job site area.
Immediate result, durable, high resistance, natural to ground water. Okay, injection technology, 3 work and step, place fire, injection, check. Okay. And this is the same idea, just different materials, right?
Yeah, just the 3 working steps are the same, and yeah, just with different materials. The big difference is this MC Montan JCB you can use that it is not foaming at all, even in contact with water. Yeah, so it's very safe. So you are just lifting and you are just lifting or fixing with the pump pressure.
Okay, MC inject CB, and this is silicate, you said?
Silicate, yeah.
Silicate.
Or right way would say to say organo-mineral, because the one side is an isocyanate and the other side is a water glass.
Injection. Okay, and main difference, no swelling, right?
No foaming.
No foaming.
So this is an example for a basement or for a foundation of a roboter. Because there were several ones of these robots and they had vibrations, yeah. And so they wanted to underpress it with injection material, so to stop the vibration and to stabilize it. Yeah. So there was absolutely no movement allowed because it's very sensible regarding settlements or lifting. Yeah. The reason why they used MC Montan JCB, because there they could be sure that there is no movement because of foaming.
Okay.
Yeah.
Yeah, please.
Again?
Finish.
Because if you use a foaming material or a material which can foam in contact with water, you cannot control the lifting, yeah?
Yeah, I understand it. Why some of the partners 45 degrees and some of them 90?
That's just to get sure that there is also material below the direct below the roboter. That was you see also an outside ring. You see 2 rings with directly 90-degree angle. So they injected at first the first ring, the outside ring, yeah. Then the inside ring, and after that they injected the material directly with this 45-degree angle under the foundation of the roboter, yeah. That was just for that project. That was just the scheme, the grid for the injection.
Yeah, Markus, who is decision maker? How to?
Wait, one second. Ja, ich telefoniere gerade mit dem Alexander Mundros. Okay, sorry.
Markus, no problem. Who is decision maker? How to put partners this way or that way? Who is finally designing this?
the applicator and the planner. Yeah.
A planner. Okay.
Done by planner and applicator. We can do a recommendation, right? We can do something like a method statement.
Mm-hmm. Okay, it means planner and applicator, they need to know how we use it, what our recommendation, and apply this to particular job site.
Yeah. Because
Okay.
it's from job type, there is no single way, right? That is that is every time from job site to job site different application.
Mm-hmm.
So the applicator has to be or has to build up experience in that kind of application. This is another job, of a slab fixing, where they had movement in the slab. So when the forklifts were driving over, the slabs started to move, and they wanted to fix that, without closing the whole business there. So they decided to use here in this case this MC Montan Jack CB. Here you see some product facts. That's approximately, if you are injecting just the joints for fixing, that's 10 liter per meter. If you are injecting below the slab for stabilization or lifting, you can calculate with 30 to 50 liters per square meter.
And this is just misprint, liter per meter.
Liter per meter, sorry. Yeah.
No problem, just... And see inject FF. This is something new.
That is new. That is a polyurethane. This FF stands for forcing foaming. Forcing foaming. So that is a rigid material also, but that foams controlled by itself 5.5 times. It's also written in the technical data sheet. Yeah. And that is these pictures are from Germany, and they are injecting under these concrete highways. They are injecting big volumes of that material. You see in IBCs, with a special truck. They are injecting it to fix these concrete slabs. There you see material coming out of the joint. So they remove the joint fillers before. Put the packers, which you can see there on the top, on the left side, put these black packers inside and inject below the slab. And since there is a pressure release, you see the joints are open, so the material can foam and go there outside. So there could not be a pressure built up. Because you just want to fix it. You don't want to lift it.
Okay. And how you remove this foam from the surface later?
You can see on the next pictures.
Okay.
You have something like that in the end, and you can easily remove it. You can just, when it's fresh, you can just put it out. I think there is there was no picture, but there is I think in other presentations there was also a picture where you can just pull it out when it's fresh. Last but not least, this is another soil stabilization. So nothing to do with slabs, nothing to do with curtain. That is just stabilizing the soil in front of the TBM.
Okay.
And here you see the red circles. That was the injection grid. 1 meter distance, approx, maybe 1.5. And the task was to stabilize the sand behind the wall. And there they used some special equipment, injection lances, RAM lances from Desui company here in Germany. Here you see the lances and the driller where they drill through the wall. Then they pushed the lance inside the soil with the jackhammer. In sandy soil that's possible. and then they started to inject, and during the injection, this device, what you can see there on the picture here, it is a pulling device. During injection, it pulls out the lens. So you're injecting material in the end of the lens. While you are injecting, this device pulls out the lens. Yeah. So you can create something like a pile in the soil.
Mm-hmm. Where? In Asia?
Yeah, in Asia. It was in Bangkok.
Uh-huh.
And this is from UK, where they had an old mine shaft or old cavity below the new railway track.
Mm-hmm.
The problem was that they couldn't fill the whole cavity because it was very deep and very big. So what they decided to is they used the soil which was between the cavity and the railway, yeah, and started there and built up something like an arc with the injection material, yeah. Go back one. All spots. No, one.
This one?
All the green spots which you see here are injection points. Yeah.
And sorry, I don't quite understand. Is it from the top?
Yeah, it's a top view. Yeah.
Top view. Yeah.
It's a top view.
Mm-hmm.
Yeah, material. And here you can see again, they use these RAM lenses. So some lenses which you're hammering inside the soil, which are open end. Yeah, only the end of the lens is open. Mm-hmm. And once you start to inject, the material just flows out at the bottom, and you can lift it up, and material is still flowing out. Yeah.
Okay.
Here you can see another device that is also this pulling device, just another type of it.
Mm-hmm. Volume square 5 liter per lens lifting. Mm-hmm.
Just testing the technique, and it is with this technique it is possible to push down this lens up to, depending on the soil, but up to 15 meter, 20 meter is possible.
Not easy job for applicators.
Again?
Not easy job for applicators.
No, but it's a good business for them.
Yeah.
So that is just an overview what you can do for the soil injection, yeah?
Yeah, I got at least a general idea. Thank you.
Yeah.
You know, for me it is important to know what to talk about with the customers.
Yeah, for this kind of things, yeah. When it comes to this kind of injection or this kind of question, you can always contact me. Yeah.
Sure. Yeah, for me important to have overview.
Then we can together up with all information, at least a method statement where everyone could see, okay, that is a technology that you need, this kind of equipment you need, and this is the way of injection which we recommend. Yeah.
Yep. This is
that is yeah, that is just for the fast pack sum. This is what you got already from the marketing stuff.
Yes, and could you give me just a few comments regarding MC
Anchor Solid?
Solid, yes.
Yeah, Anchor Solid is an epoxy-based anchor glue, yeah, which you can use for all different kinds of fixing of components, also of rebars, of threaded rods. Yeah. It's like it like the things we know from Fisher and Hilti.
Sorry, I didn't hear last sentence. Can you repeat, please?
It's similar or it's something similar which Hilti and Fischer are selling. Yeah, this anchor glues.
Okay.
It's to install some components for example, if you want to fix a handrail, yeah, to the there you need some connectors, yeah, and that is in the end a rebar or a threaded rod. And this kind of applications you can do with the anchor solid.
Right. Yeah. Okay, and you have synchro system components, but in addition, you need to have MC fastpack gun.
Yeah, you need the fastpack gun, and for Canada, you don't need this equipment tool. You can just use something what you have there. What you need is the material and the handgun, and maybe the handbook to see the working steps.
Okay, this is like technology, step by step. Okay.
Yeah.
I got it. Yeah, Markus. Anything else for today, because we are running out of your time?
Yeah. No, not yet. I'm just preparing a new presentation, which when it's ready, I will share it with you. Yeah.
Okay.
It's a little more about method of application and so on. Yeah, so that you can see a little bit more about the type of application. Yeah.
Yeah, I got it. Okay, Markus. Thank you so much. I am much better prepared. I am still, not expert, of course.
You don't have to be expert.
Yes, but I have much better understanding of the area of application and some of our advantages. This is what I wanted to have, to be, more confident when I talk to customers, and really appreciate your efforts and your comments. Thank you very much. Last but not least, we discussed test. I would like to check myself with the test, because if there are
I have it on my list.
Yeah, send it to me, because when I see that there are wrong answers, I can check again this presentation and learn a little bit more.
Yeah.
Great. I think that's it. Ready to go for another trip. Yeah. Thank you. Have a good time, and yeah, please.
Yeah, you too, and I hope to see you soon. Yeah, with new injection projects.
I hope very much. Yeah. Thank you, Markus. Yeah.
Okay.
Yeah. Okay. Thank you.
Have fun and success at the conference.
Thank you very much.
Best regards to Evgeny.
Definitely will do.
Bye.
Bye.